So I want to do a little bit more examples of some prisms. A lot of you guys had questions on this surface area and volume problem from the worksheet. And this is going to be a little bit different. Same idea. So I wanted to just hammer home a couple ideas. For volumes of all prisms, and again, a prism is a three-dimensional shape with top and a bottom that are the same, and it's connected by these lateral faces. So imagine, again, we have two triangles connected by the lines, with this line kind of, you can't see it, but running in the background of that. If I wanted to show you the insides of this, it would look probably something like this, right? We just can't see it with that, you know, the line going up the back end of it. But this would be a prism, right? And a lot of you guys had questions on how to get not only the volume, but the surface area. So let me talk about it. So for the volume, you really just want to find the area of the base or the top. It doesn't matter. So you could think of it like find the area of the base triangle down here, or you could think of it like the area of the top triangle. You're just trying to figure out how many squares and or cubes would make one layer. Think of that tower problem we did last time. And then you could, once you know how many are in one layer, you can multiply by 11, because that would be, you know, how many layers or the height of this actual 3D shape. So to find the area of one of these layers, I just need to find the area of this triangle. And the area formula for a triangle, again, is area equals 1/2 the base times the height, which you guys already know. And I just need to know the base of this triangle and then the height of the triangle. Well, the base of the triangle is this whole length, which is going to be the same as this length, so that'd be 10. So triangle area equals 1/2 the 10 times the height, and the height would just be that vertical perpendicular height from there. So that would just be 4. Sometimes it might be helpful if you actually were to, I don't know, disassemble the shape a little bit. So like actually just draw it two-dimensionally. So like this would be 10, this would be a 4, right? That would just be this detached from that, right? So that might be helpful if you're having a hard time kind of just visualizing this. So let's go ahead and calculate that. Triangle area equals 1/2 of 10 is 5 times 4 is 20. So that would just be the area of that triangle. That's how many squares and or cubes would fit into that triangle perfectly. And then once you know one of those layers, which would just be the base area, you could multiply it by the height, and that would be the volume. So the volume would be 20 times 11, and 20 times 11 would be 220. So 220 units cubed, if you're being fancy there, would be the volume of this prism. Now the surface area, you would have to, again, think of how many sides or how many faces does this have, and we'd have to find the area of all of those. Good news is we already have 2 of them, or the information for 2 of them, because the area of this triangle is going to be the same as this triangle. That's kind of, you can't really see visually. So the top and the bottom of the shape. So really we have 2 of these triangles, and if we know the area of one of them, we could just double this, and that would be the area of both. So the area of this guy, again, is 20, and the area of this guy also is 20. So if we're going to find the surface area, 20 plus 20, well, the top and bottom, there's 40. But there's more to this than just the triangle on top and bottom. There are also these rectangles, really, that are formed by connecting that one triangle to the other. And the number of rectangles there would be technically 1 that you see out front, and then the 2 that are kind of facing the outward sides. So the dimensions of this rectangle out front are just 10 by 11. So we have a 10 by 11 side. We have 2 sides in the back, and I'm just kind of dismantling this shape into all its pieces, right? So the other rectangle would be like this, 7.2 by 11. So 7.2 by 11, so we'd have to find the area of that. And then the other one would be this 5.7 by 11. And that would be my other area. So 10 times 11, let's see here, is going to be 110. 7.2 times 11 is going to be 79.2, and then 5.7 times 11, that's going to be 62.7. So not only do we have a top and bottom area of 40, but we have to also add in 110, we have to add in 79.2, and we have to add in that 62.7, and that will get us our total surface area for all 5 sides of this prism. So let's see, top and bottom is 40 plus 110 plus 79.2 plus 62.7. I got 291.9. And that would be units squared because, again, we're talking about area. And that would be how you could find a surface area for that. So for those of you guys who are wondering, who are struggling, that is how you do a problem like that. Next, I want to get into some more complicated prisms. So we're going to do that now. So what I have here is a regular hexagonal prism. So on the top and bottom, you have this regular hexagon with, 6 sides. Each of the sides are the same length, and they're all 4. And then we know that this tower, or this whatever we want to call it, is 12 high. So what we're going to do is we're going to start, like always, we're going to get the volume, and then we'll get the surface area momentarily. To get the volume, I would need to know what the area of that slice is, right? So I need to know how many boxes or cubes, if you will, fit on that, and then I can multiply it by 12 because there are 12 layers of it. So I need to find the base area of this prism. So I'm going to just redraw this hexagon. This would be the top and bottom, would look like this, and its side length is 4. From the last unit, we know how to find the areas of this, so I'm going to just quickly do this. Split this into triangles, right? Take 360, find the central angle, divide it by 6, and that would get me that guy. So I'd have 4, 360 divided by 6 is 60. And if I were to split this up, because I need the height of it, don't forget this number would be split. This would be a 2. I would want to figure out what that is, and then this number would be split as well. It'd be a 30, right? Then I would set up a tangent problem. Tangent of 30 equals opposite over adjacent. I would do some magic, cross multiply and all that fun stuff. This times this. So y times tangent of 30 equals 2. Divide both sides by tangent of 30 if I'm trying to be exact here. Tangent of 30, and y would equal whatever 2 divided by tangent of 30 is. So I'm going to do that on my calculator that I have here. It's 3.5 roughly. So that would be my height, right? So if I were to go back to this triangle here, it'd be a 4 on the bottom, and then the height of it would be 3.5, right? So if I'm trying to find the area of just this, base area of this polygon, right? It would be 1/2 4 times 3.5. That would be the area of just one of those triangles, right? So I'd get, let's see, when I calculate that, I get 7. So that'd be the area of just this triangle. And then remember, there are 6 of them. So to find the hexagonal area, I would multiply that 7 times 6. So that would be 42. So the area of this polygon up here is roughly 42. That would be the base area here. And, 12. So I would multiply by 12 because there are 12 rows of that. And that would be what my answer for the volume is. So 42 times 12, 504 roughly units cubed, right? Now, for the surface area of this, you would have the top and bottom be this, and we've already got that, which is awesome. We already found that it's 42. We got 2 of those, so imagine 2 of those. So to get the surface area, obviously, we'd already have 42 times 2, because that would give me the top and bottom. So this would just represent the area of the top and bottom of this prism. But going around the outsides, you have a bunch of rectangles. Now, how many rectangles would there be? If you got 6, you are correct. Now, what would the dimensions of 6 of these rectangles be? There's 6 of them, right? But what would the dimensions be? Well, 12 would be the height of it, right? And each width would be the sides of the polygon. Because they're all 4, all these rectangles are going to look like that. So we just need to find one of these areas. 4 times 12, so that's 48. And there are 6 of these rectangles, right? So 48 times 6 would be all the areas added up of all those side rectangles, and that's going to be 288. So this would be the top and the bottom. This would be all the side rectangles. They're the lateral faces. So we'd add the... So 84 plus 288, that would be 372. And that would be my surface area for that polygonal prism, right? Okay, one last one, and then we're done for the day. Let's talk about cylinders. So cylinders are also prisms. They just look a little funkier, but if you think about it, it's just a shape and another shape, and I can draw the hidden part of it, but 2 circles connected on all of its sides straight down. So this technically is a prism as well. So I'm going to start with the easy part. Let's do the volume. So the volume of a prism would be the base area. Again, we got to find the area of that base shape, and we can do that. So that circle, the radius of 5, right, would be found by just doing pi r squared, so pi 5 squared. So that area would just be 25 pi, or 25 pi, which is approximately, what, 78.5? So that would just be the area of just that circle. And if I know that's how many boxes or cubes would fit into one layer, there are 10 layers of that. So this volume would just be the base area, 78.5 times 10. And that would give me approximately 785. So that would be my volume. Again, not really hard to do cylinders when it comes to volume. Now, surface areas, on the other hand, this is going to be a little obnoxious. I know that obviously the top and the bottom are circles, so I could just take this area and double it, right, to get the area of the top and the bottom. But what about this side? Let's see how we could think about this. So I guess the best way to explain this would be to take a look at a cylinder. So I got me some breadcrumbs. I went all the way to the store just to get these guys. Had to eat them because obviously I do not want to waste anything. So yeah, I just ate like a whole entire container. I'm just kidding. Anyway, so we got a cylinder, right? We can clearly see that the top and the bottom, that's a circle. So if I'm gonna get the surface area of that, I could just find the area of this circle, area of the same circle on the bottom, right? That's not our problem. The problem is the lateral area. It's this surface around it. How the heck am I going to be able to find the area of this? Because it doesn't seem like, like rectangles, like some of the other shapes that we've been doing, like something that we have been doing, because it's, it's round. So like, what actually is that shape if I were to flatten it out? So luckily for y'all, got some scissors. Let's figure out what shape this is. So I'm gonna go ahead and pop the top again, and I'm just gonna scissor my way down. And through the power of editing, I have scissored all the way straight down. And in fact, I've actually cut off the bottom. Now, let's see what ends up happening. So now that that's all cut, let's see what shape that actually is. And if you take a look at it, that just looks like a friggin' rectangle. And it is. So the lateral surface area of the cylinder, or at least the side, is just really, honestly, when you flatten it all out, just another rectangle. Now, clearly we know, usually they'll tell you the height of these cylinders, right? Which would just be the distance from top to bottom. But how do I figure out, for instance, the width of this? So like from here all the way to here, how would I figure out that? The good news is that this distance is really, if I were to fold this back up, the same distance around that circle at the bottom, aka this would just be the circumference of the circle if I were to put that out. So if I know the circumference of the circle, which I can easily find, I could find the width of this rectangle, and I probably already know the height of the cylinder, which would be the distance from there to there. So I could easily find the area of the lateral surface. So now that we know that this lateral surface is really just a rectangle, right, sprawled out like we did with the breadcrumbs, let's go ahead and figure this out. So I know that this length and this length are corresponding, it's 10, but this part of it would just have to do with the circumference of the circle. So to figure out what this length is, I just need to know what the circumference of the circle is. And the circumference of a circle formula is 2 pi r. And, well, my radius is 5. So this would just be 2 pi times 5. Or another way to think of that would be 10 pi, right? Or you could just think of this as its decimal form. So 10 pi is 31.4. So the length of this would be 31.4. The height of this would be 10 because, again, that just connects to the height of that prism. So that the area of this would be 31.4 times 10, which is about 314. So that would be the area of the lateral face of the cylinder. And then we got, again, the top and bottom circles that we have to add with it. So the surface area would just be this times 2, right, for the top and the bottom. So 78.5 times 2 is going to be 157. That would represent my top and bottom. So that's just this times 2. And then I got my lateral surface, which is that rectangle, 314. I'm going to add these up. So 157 plus 314, and I get 471 units squared. That would be my surface area. So hopefully this is enough to kind of get you started. Today's assignment is just going to be practicing more prisms, cylinders, polygons, rectangular prisms, triangular prisms. If you have any questions, office hours again are daily, Monday through Thursday, 1 to 2 p.m. If not, you guys have a wonderful day.